Hey, I'm Dr. Thomas C., the head of science at NASA, and I'm really excited to talk to you about the two questions that I'm supposed to address. The first one, of course, is what is the most exciting thing we have accomplished this past year? And I want to point to two pieces. The first one is when COVID struck, we came together between the European Space Agency, the Japanese Space Agency, and NASA and created a COVID dashboard, bringing together all of our data, really working as an integrated team towards providing information for decision makers. I think that was just a hugely important demonstration of how we can work together. So that would be my first answer. The second one is the launch of March 2020 Perseverance, which is the first leg of the first round trip to Mars for humanity. And so we did that in the middle of COVID, and that is a second milestone that really matters. So as we look at the next year, what am I most excited about? And especially things that will change life on Earth. Well, first of all, we have a number of missions, 8 in fact, that will launch. 2 of them will look at the Earth, such as our Landsat mission, together with our cross-agency partners, and GOES, which is a weather satellite that we do also with our cross-agency partners. And those are really critical together with the others. I want to also tell you that I do believe that it's life-changing to do amazing research, and the highlight of this year for us will certainly be, together with others, the James Webb launch. And we're really excited for that. A launch for the Asia is one that we've been working on for almost 20 years. So I couldn't be more excited to talk to you about both last year and this year, and just really hope you're joining us as part of the international community to change life on Earth to the better in the future years. Thanks for your engagement, your involvement. Appreciate it. Bye-bye.
Hi, my name is Dr. Nikki Fox, and I am the director of the Heliophysics Division at NASA headquarters. First of all, congratulations to all of the winning teams for this year's Space Apps Challenge. And thank you so much for allowing me the opportunity to record a short video for your virtual winners celebration. Your interest in Earth science, in space science and exploration is truly inspiring, and I'm really blown away by your creativity and the innovation you put into developing these solutions using our NASA data. I wanted to share with you a little about what's happening in heliophysics, the holistic study of the sun's influence on space, Earth, other planets, and interstellar space. We like to say that everything the light touches encompasses heliophysics, much like the Lion King. There are always lots of exciting things happening in the division, but I wanted to share just 2 personal highlights with you from 2020. The first was the launch of Solar Orbiter, a mission to go and really look and study the poles of our star. And we launched Solar Orbiter in February of 2020, so just before the pandemic hit, and we're very excited, already getting great data down from that mission. The second highlight for me was Parker Solar Probe, the completion of the 4th, 5th, and 6th perihelia, flying very close through the sun's corona, giving us this in situ data of where all the magic happens with our star and its transition to the solar wind. The study of heliophysics, of course, is important to understanding the impacts of space weather, and our fleet of spacecraft and research are really helping us to forecast and to really improve other models that we use to predict space weather and how it impacts life and society. I mean, just imagine if your cell phone and your tablet, etc., just stopped working or kept going out. So heliophysics is always working for the benefit of all of humankind. It certainly is a great time to be a heliophysicist, and we look forward to working with all of you, the next generation of scientists, technologists, designers, storytellers, engineers, and problem solvers. Thank you so much, and congratulations again.
For as long as humans have known how to write, they have written about the unknown reaches of the universe.
Every human culture has asked, where did we come from? When we look up at the night sky, questions spring immediately to mind. How did the familiar night sky of galaxies, stars, and planets come to be? How does the universe work?
Some of the biggest questions we now understand: that the sun is at the center of our solar system, that Earth formed with it around 4.5 billion years ago, and that the universe is over 13 billion years old and filled with countless galaxies. But some of our deepest questions remain unanswered. What forces shaped the universe across that span of time? How do the galaxies form? How do the stars form? And do they have planets like our own in orbit around them?
We began developing the Nancy Grace Roman Space Telescope to provide some answers to these questions. In February 2020, NASA formally confirmed its plans to build this new space observatory for launch in the mid-2020s. The Roman Space Telescope's main science goals include investigations of cosmology, or the study of the universe, and planets around other stars. Roman's observations will help us understand how dark energy and dark matter, which make up most of the total content of the universe, have led to the growth of galaxies across cosmic time. Other observations will survey stars in our own galaxy to search for rocky planets in the habitable zone around stars where liquid water might exist on their surface. Roman can make these groundbreaking discoveries thanks to major advances in technology since the launch of the Hubble Space Telescope in 1990. Roman's mirror, which gathers light from distant objects, is the same size as Hubble's and will produce images just as sharp, but it can see over 100 times more area than Hubble. It is also many times more efficient in how quickly it can take images, so years of Hubble observations could be conducted in mere days with Roman.
But even once we have made exciting discoveries about the universe with Roman, an enduring question remains: is there life on planets around other stars?
Roman also has an experimental instrument designed to block the light of a star so that we can see the planets orbiting it and measure their light directly. It's the first step we need to take in learning how to characterize these distant worlds.
NASA has been studying how to take the next leap, to develop an observatory that can tell us what planets around other stars are really like. Building on the technology of Roman, in the coming decades, we expect to be able to make a more capable space telescope that can sense distant planets as small as Earth around stars like the Sun. Most importantly, that future telescope would reveal what's in the atmospheres of those planets. Astronomers a generation from now will study these planets and look for the kinds of things we see in our own atmosphere: water vapor, carbon dioxide, oxygen, and more. The right combinations of these and other molecules will tell us whether conditions on the surfaces of these planets are similar to those on Earth, or different, and whether there might be life on them.
NASA's Astrophysics Division is working to make this future a reality. Today, we can address the ancient questions scientifically. Soon, we will finally learn whether there is life out there.
The universe has many secrets yet to be revealed. With NASA Space Apps, you can help the Astrophysics Division in this quest.
Hello, and congratulations to all the winners of the NASA Space Apps Challenge. Way to go. Good job. I'm Lori Glaze, and I am the director of NASA's Science Mission Directorate Planetary Science Division. And I'd like to share with you a few of the really exciting things that are going on in NASA's Planetary Science Division. One of the most exciting things that has happened over the last year was actually the landing of Perseverance rover just a couple weeks ago on February 18th. We were able to deliver successfully to the surface of Mars the Perseverance rover along with its little sidekick, the Ingenuity helicopter. The Perseverance rover is going to be exploring a special place on Mars called Jezero Crater. And Jezero Crater is important because we believe that there was actually water present in the crater 3.5 billion years ago. And there were sediments delivered. There's a big river delta there that if life had formed at that time, it's about the same same time life started to form on Earth, that life, those microbial fossils might be preserved in that river delta. And so Perseverance is about to embark on its incredible science journey, and the Ingenuity helicopter is about to demonstrate the first powered flight on another planet. So that is really exciting technologically, and we expect great science from that mission. But we also had another great science delivery over the last year. Last October, our OSIRIS-REx mission was able to successfully collect a sample from the surface of the asteroid Bennu. This asteroid at the time was 200 million miles away, and we were able to actually collect that sample and store it for return back to Earth. And this is important because asteroids also contain some of those early building blocks that made up the planets in the solar system and would have delivered the water and the organic molecules required for life to Earth and to other places in the solar system. So by bringing that sample back to Earth, we can study it in our laboratories and better understand how life actually came to be on Earth and how our solar system formed and evolved. Very, very exciting. And thinking ahead and thinking about some of the things that can make a difference to all of us here on Earth, I'd like to talk for just a minute about a field we call planetary defense. Planetary defense is something where we are looking for, identifying, and characterizing asteroids and comets that could potentially be hazardous to Earth if they were to ever impact Earth. And so we have, as part of Planetary Science Division, the Planetary Defense Program, which searches for and characterizes those near-Earth objects. But just this year, in 2021, we're also going to launch a mission called the Double Asteroid Redirection Test, or DART. And DART is going to visit an asteroid, a double asteroid system with the asteroid Didymos. It has a little moon called Dimorphos, and we are going to fly DART to that binary asteroid system and impact the spacecraft into that little moon Dimorphos. This is called the kinetic impactor technique, and the intent is to change the orbital period of that small moon just a tiny bit. And this will help us to better understand and calibrate our ability to eventually divert or just change the orbital period of a potentially hazardous asteroid that might be on a collision course with Earth. So that, of course, is very important to all of us living here and wanting to do so for a long time to come. So thank you very much. And again, congratulations.